things I'd like to show you is one of the challenges that my students have is when they have a unit circle that don't have all of these angles on it, what they sometimes have a difficult time seeing is if I put, let's say, a pi over 4 here. If I put a pi over 4, a reference angle right here, sometimes my students have a difficult time sometimes they have a difficult time acknowledging what this angle is. It's easy for you to maybe see that, hey, that's pi over 4. That's pi over 4, and you can just look right here and see that this angle in radians is 7 pi over 4. It's easy for you to see that. But sometimes my students, when I don't have all the angles here surrounding a unit circle, it's difficult for them to see that this is pi over 4. Or, excuse me, that this is 7 pi over 4. Excuse me. The thing I want you to be able to see is this degree measure is 2 pi. This degree measure is 2 pi. And another way to say 2 pi, written as a fraction, is 8 pi over 4. This is the same thing as 2 pi. 8 pi over 4. I don't know if you can see that. Can we go there? Maybe that a little bit better. Oh, wonderful. So that's 8 pi over 4. All right. So if this all the way around is 8 pi over 4, and oh, by the way, I am intentionally using a denominator of 4 because this is pi over 4. I'm intentionally identifying 2 pi as a fraction with the denominator of 4 because I have intentions on making a calculation with these two angles. All right, so if they wanted to identify this angle, they could keep in mind that all the way around, which is an angle that's actually larger than this one that you want, that's 8 pi over 4. So what you could do is take the 8 pi over 4, subtract pi over 4 to get 7 pi over 4, which would be an answer to this problem if that pi over 4 is a reference angle. This is one of the challenges that my students have, and I imagine other students have as well. All right, so we're just going to stay with this topic just for a minute. Let's say you have a reference angle of pi over 3 here, and you've got to identify what that answer is. This is pi over 3. It's pi over 3. What degree measure is that? What degree measure is that? Students in trigonometry have challenges identifying what that angle is from here to here. But what I'd like you to be able to see is that from here to here is 180 degrees, but another way to say 180 degrees is pi. Another way to say 180 degrees, we showed you how to do that before. 180 degrees, we showed you how to do that. You could multiply by pi over 180. 180 is canceled, and you just left with pi radians. All right, so this is pi. Now, another way to say pi is 3 pi over 3. All right, that's pi. I'm intentionally using the denominator of 3 because this angle that I have that I want to learn more about, that has a denominator of 3. I would not use the denominator 4 like I use here. The reason why I use the denominator of 4 here was because my angle in question had a denominator of 4. I want to find more about an angle that has a denominator of 3. So I'm identifying this angle here, which is pi. Another way to say pi is 3 pi over 3. Now, if I want this angle, I need to take the 3 pi over 3 and add pi over 3, and you get 4 pi over 3, which is the measure of that angle. It's the measure of that angle. Notice how we showed you that really already here. But in trigonometry, sometimes you have to be able to get this angle without having access to this unit circle. Here, I've shown you earlier that a reference angle of pi over 3 was already 4 pi over 3. But you would not have access to this in the context. You would not have access to this when completing this problem here. And let's take a look at a problem. Let's say you have coordinate system, and let's say you have an angle here that is pi over 6. Pi over 6. And you are trying to determine, all angles are measured from this axis here. So you have to identify what angle is that. What angle is that? And the way you do that is to, again, remember that that's pi. Another way to say pi is 6 pi over 6. Notice how I did not say 4 pi over 4. Notice how I did not say 3 pi over 3, because the denominator here is 6. The fraction that I'm using here to represent pi needs to have a denominator of 6, and 6 pi over 6 is perfect. All right, so you want to know not what 180 is, or not what pi is. You want to measure this angle from the x-axis. All right, so if you do that, you would go 6 pi over 6, but then you've gone pi over 6 too far. So you take 6 pi over 6 back pi over 6. You go 6 pi over 6 minus pi over 6. 6 pi over 6 minus pi over 6 is 5 pi over 6. And that would be the answer to this particular problem. 5 pi over 6. All right?
Yeah, I want to know how you get pi. I mean 5 pi.
How do we get
from the 6?
From
was that was it like 6 take away 1?
Okay, you talking about
the one you just did.
The one
you flipped
oh, okay, my fault.
Right.
All right. Okay, so okay. How'd I get to 5 pi over 6?
I see the 6 pi, and then over 6, then you got pi over 6, but it ended up 5 pi over 6. Was that like 5 take away, like saying 5 take away, 6 take away from 1?
Yes, sir. Yes, sir. See, what this is this all the way around, that's the same thing as pi, which can be rewritten as 6 pi over 6. But see, I didn't want that. Sir, I did not want that. I wanted this angle right there.
Okay.
So what I had to do is I had to go 6 pi over 6, and then I had to subtract pi over 6 because I never wanted that in the first place. I was just using this as a means to getting that.
Okay.
So I took 6 pi over 6 minus pi over 6 to get this angle that I wanted. And that's how I got 6 pi over 6 minus a pi over 6, which is 5 pi over 6.
Okay, I got it.
Okay, I know you're doing something different right now as far as pies, but my concern was with trigonometry. And I guess the right angles, the 30, 60, 90 rule. Mm-hmm. I always get confused about where we're doing the sine, the cos, and the tan, and then when it comes to like doing the hypotenuse side and adjacent side and the base, I get confused in that, and I don't know which way to go.
All right, let's take a look, okay? Let's take a look. Now, you might just be watching the show, but one of the things that I did, I talked about how the adjacent, you can use adjacent in an everyday sentence. If there was somebody sitting right here next to me, they're sitting adjacent to me, which means next to. And that same definition we use in everyday life, we're going to use in math too. And then if somebody were sitting right here looking at me, I would be opposite of them. If they're looking at me, I'm looking at them, they're opposite me. We use that in everyday language, and we're going to use it in math. And if you can remember those definitions of opposite, meaning across from, and adjacent, meaning next to, this math is going to be simple, okay?
Okay.
All right, so let's take a look at this triangle, remembering those definitions, all right?
Okay.
All right, so now, and another thing, what I want you to do is when you hang up the phone, go to this my YouTube channel, Dominate Math, and you can see how we talked about some of this stuff earlier in the show, okay?
Okay.
Dominate Math on YouTube. All right, so here we go. Let's take a look. You see how you got that this 60-degree angle? 60-degree angle.
Yes.
To determine like the cosine, determine the cosine of 60. One of the things that you're going to have to remember is that cosine, by definition, means the adjacent of 60 divided by the hypotenuse of 60. You want the cosine of 60. You want the cosine of 60. You need the adjacent of 60 divided by the hypotenuse of the triangle. So adjacent means next to. Adjacent means next to. So a hypotenuse is the longest side. Hypotenuse is always the side opposite that 90-degree angle. So what side do you think is adjacent to the 60? Remembering that adjacent means next to.
Oh, the 90.
Oh, no. It's a side. It's a side. It's either this, or this. What side is next to the 60? See, we're going to do a couple together. I want you to be able to see that the 1 is next to the 60.
Oh, okay. I understand. I understand what you're saying.
Yeah, see, this 1 is next to the 60.
Okay.
So cosine, by definition, is the adjacent of the 60 over the hypotenuse of the 60. So the adjacent to this 60 is 1. And the hypotenuse of this triangle is 2. The cosine of 60 is half. The cosine of 60 is half. All right, so I want to do a couple more. We only have a couple minutes in the show, but again, what I want you to do is I want to direct you to that YouTube channel, okay? Dominate Math. Let's try to do another one. Running a little bit short on space here, but let's say we want the tangent. Let's say we want the tangent of 30. Let's say we want the tangent of 30 degrees. All right, so the tangent of 30 degrees. One of the things you have to go into the problem knowing is what tangent means. Tangent, by definition, is the opposite over the adjacent. So tangent, by definition, is opposite over adjacent. So the tangent of 30, you want the opposite of the 30, and then you want the adjacent of the 30. Okay, now you got to know what those words mean. Opposite means across from. Adjacent means next to the 30. All right, so this is the 30-degree angle right there. That's the 30-degree angle right there. The tangent of 30 is the opposite of the 30 divided by the adjacent of the 30. What is opposite of this 30? Which of these legs are opposite of the 30? Across from this 30.
1.
Amen. 1. And which of these legs are next to the 30?
See, this is what confuses me.
Yeah. Yeah, and I know why. And I only got a half a minute to explain to you why. Hey, you saying, hey, that 2 is next to the 30, and the radical 3 is next to the 30.
Yes.
Amen. Hey, what you got to remember is the 2, which is across from the 90, that's always a hypotenuse.
So it's square 3.
Amen.
Okay.
You have just dominated math.
Okay.
All right, but we got to go. Why do people always call at the end of the show?
I just
We got one.